bond is special. It's just a dipole-dipole interaction, but it's super strong and it's very important, and so we give it its own name. So, how do we get a hydrogen-hydrogen bond, or sorry, a hydrogen bond? So we know that you get polar bonds if you have two atoms that are bonded to each other, where one is way more electronegative than the other. You get this dipole going on. Well, what are the most electronegative atoms? Fluorine, oxygen, nitrogen, are some of the most electronegative atoms. So you can imagine that if I had fluorine bonded to a hydrogen, this covalent bond is going to be super polar. Okay? Because it's super polar, its charges will be higher, which will make the force of attraction stronger. So, in order to have a hydrogen bond, my first molecule needs to either have an FH, an OH, or an NH bond in it. Okay, it doesn't mean it needs to have a nitrogen and a hydrogen in it. It needs the nitrogen-hydrogen to be bonded to each other. Okay, so if you're in a really good mood, you could even say that hydrogen bonding is pretty fun. Haha, thanks. Okay, so again, thing 1 needs an FH, an OH, or an NH bond. Thing 2 then needs to have an F, an O, and an N in it. Okay, these in the second molecule, they don't have to have hydrogen. They can have a hydrogen, but they don't have to have hydrogen. So an example of this, well, I could have this molecule. Okay, this molecule has dipoles on it. Hydrogen is going to be a little bit positive. Nitrogen is going to be a little bit negative. Okay, and what if this came close to that molecule? This has an oxygen on it. That oxygen is bonded to a carbon, which is going to make it pretty negative because it's pretty electronegative. Well, hopefully you can see there's an opportunity for opposite charges to be attracted. Okay, so again, thing 1 has an FH or an OH or an NH in it, and thing 2 has an F or an O or an N. They don't need to be the same. The FH doesn't have to be with an F. You just need one of each. And that is a hydrogen bond. Okay, so zooming back, a pretty little chart. Hopefully this gives you an idea of what the different intermolecular forces mean. Now this chart is listed in terms of increasing strength or decreasing strength, whatever. But going up, the strength increases. So why is that? Well, because the force of attraction, I know I've said this a million times, is just based on the charges that are felt and the distance between those charges. So if I have stronger charges, I'm going to have a stronger intermolecular force. So looking at this, what's the strongest charges? Well, ion charges are full all the time, full permanent charges. That's going to be stronger than a dipole, which is partial permanent, and induced dipole, which is a partial temporary charge. And then the other ones fall in between there. So for some reason, a lot of people like to get the opinion that hydrogen bonding is the strongest intermolecular force. That's just not true. Ion-ion is stronger, but we do talk about how strong hydrogen bonding is. Hydrogen bonding is the reason that water molecules will, why you can fill a glass with water over the rim and it doesn't spill out, because those hydrogen bonds in the H2O molecules are so strong that it will create kind of like a dome or a little bubble before it spills out of the cup. Or same reason you could get a water droplet under your finger and it will just hang there because hydrogen bonds are strong. But ion-ion bonds are stronger, which is why water is liquid at room temperature and why salt is crystal or solid. Okay, so this is all good and fine. Hopefully this helps you understand conceptually, but what you really care about is the homework. So I have the homework here, and I just want to go through a couple of them to show you how I would think about these intermolecular forces and how to answer these questions. So I'm going to start with number 5 because I think it answers the question, or it explains the thought process, helps us with the thought process. So again, my options for intermolecular force are ion-ion, ion-dipole, hydrogen bonding, dipole-dipole, dipole-induced dipole, and induced dipole, or London dispersion. Okay, so this is how I think about this. it asks for the dominant intermolecular force. So what we're going to do is we're going to start at the top of the list of intermolecular force strengths, and we're going to go down until we find one that applies